Good morning, everyone. My name is Zhu. My research topic is application of phase-changing material immersion in building. First, let me introduce the phase-changing material. Phase-changing materials refers to substances that emit or observe a large amount of heat during the phase-changing process to achieve heating or cooling. Simply put, it is a conversation of matter, solid, and liquid. For example, the water is the most common phase-changing material. Next, I will introduce the sensible heat storage. As can be seen in the picture below, sensible heat refers to the storage or release of energy in response to temperature changes. The formula for sensible heat can be expressed for the following formula. Q expresses the quantity of stored energy. M equals mass. C is specific heat, and T is temperature change. But sensible heat has many drawbacks. Firstly, it will cause heat loss problem. Secondly, it has a heat storage density and poor efficiency. Next, I will introduce latent heat storage. As can be seen in the picture below, latent heat is the storage or release energy through changes of the matter states at a constant temperature. Utilizing latent heat, one can manage the controllable storage and release of the heat at constant temperature. Firstly, latent heat has high energy storage density. Secondly, it has a small temperature vibration in the energy storage and release process. Because PCM has high latent heat ability, if PCM can use in building application, it will reduce energy consumption. As can be seen in the picture below, the cement is mixed with the phase-changing material. During the daytime, the temperature rises and the phase-changing material absorbs heat. And in the evening, the temperature drops and the phase-changing material begins to release heat. A controllable temperature for people is achieved through heat absorption and heat release to make people to live in a comfortable environment. But the phase-changing material needs to be well attached to the wall. So it needs to be made into a high viscosity phase-changing material, like toothpaste. Next, I will introduce the experiment about phase-changing materials. I chose hexadecan as phase-changing materials. The reason is this material melting point is 18 degrees. This temperature is comfortable for people to live in the building. But hexadecan is not stable between solid-liquid transition. So I use the cellulose nanofiber to capture the hexadecan to protect the hexadecan leakage. And the cellulose nanofibers can improve heat storage efficiency. And cellulose nanofibers has biodegradability and biocompatibility. So it is not harmful for people and can be used in building application. So I use a homogenizer to mix the cellulose and hexadecan to make an immersion. Next, the prepared immersion was subject to Fresnel test and microscope test. The PCM is used as building application. The temperature variation is from -20 degrees to 25 degrees. Therefore, first, place immersion in a freezer at -20 degrees. And after 3 hours, place the immersion in the freezer in a water bath at 25 degrees to melt, and observe the particle size change of the immersion through a microscope. Now, after the 5-cycle Fresnel test, cellulose nanofiber 0.7 weight%, hexadecan 30-40 volume% are stable. But cellulose nanofiber 0.7 weight% hexadecan 50 volume percent immersion sample has been cracked. Observing the microscope, there is no significant change in the particle size of the two immersion. In detecting the stability of the immersion, the latent heat of the immersion is measured by the DSC. Different scanning telemetry is used to measure the heat release or absorbed by a sample when it is heated or cooled within a specific temperature range. The DSC test temperature is one cycle from 25 degrees to -30 degrees. After 5 heating and cooling process, it is found that as the volume fraction of hexadecan increases, the latent heat has increases in a linear relationship. And when the volume fraction of hexadecan is 40 volume percent, the latent heat reaches 18 joule per gram. The above is the content of my announcement. Thank you for listening.